Welcome to this lesson on symmetric and asymmetric encryption. In this lesson, you will learn why encryption is needed, what plaintext and ciphertext mean, how symmetric encryption works, how asymmetric encryption works, and how to compare the two methods. Encryption is important because data can be intercepted while it is traveling across a network. A person who secretly intercepts data is called an eavesdropper. Encryption changes readable data into an unreadable form. This is useful for protecting sensitive information such as bank details, passwords, and medical records. Encryption does not stop interception, but it stops the intercepted data from making sense. The original readable message is called plaintext. After encryption, it becomes ciphertext. Ciphertext is scrambled and unreadable. Decryption changes ciphertext back into plaintext. For example, if a key shifts each letter by 3, the word hello could become coor. Symmetric encryption uses one shared key. The same key is used to encrypt the message and to decrypt it. The sender uses the key to lock the message, and the receiver uses the same key to unlock it. A simple memory tip is that symmetric means same. Here is a simple example. Suppose the message is cat and the key says to shift each letter forward by 3. C becomes F, A becomes D, and T becomes W. So cat becomes FDW. To decrypt it, you simply shift each letter back by 3. Symmetric encryption has some advantages. It is fast, it works well for large amounts of data, and it is easy to understand. But it has one major drawback. The key must be shared securely. If the key is stolen, the attacker can read the message. This is called the key distribution problem. Asymmetric encryption uses two different keys. These are called the public key and the private key. The public key can be shared with everyone. The private key must be kept secret. A simple memory tip is that asymmetric means different. Asymmetric encryption was developed to solve the shared key problem. In symmetric encryption, the same key has to be shared somehow. In asymmetric encryption, the public key can be shared openly and the private key never needs to be sent to anyone. Anyone can lock a message using your public key, but only you can unlock it using your private key. Let us look at an example with Jane and Tom. First, Jane creates two linked keys, a public key and a private key. She sends her public key to Tom. She keeps her private key secret. Next, Tom uses Jane's public key to encrypt the message he wants to send. Once the message is encrypted, it becomes ciphertext. Tom then sends the ciphertext to Jane. When Jane receives the ciphertext, she uses her private key to decrypt it. Only Jane's matching private key can do this. The public key encrypts and the private key decrypts. Asymmetric encryption is very useful because one user can receive secure messages from many people. Jane can share her public key with Tom, Susan, Mike, Megan, and others. They can all use her public key, but only Jane can use her private key. Now compare the two methods. Symmetric encryption uses one key and the same key encrypts and decrypts. It is usually faster, but the key must be shared securely. Asymmetric encryption uses two keys. The public key encrypts and the private key decrypts. Its main strength is solving the key sharing problem. Here is a simple example. If a company wants to send a secret file to a new customer over the internet, asymmetric encryption is better at the start. This is because the customer can share a public key openly while the private key stays secret. This avoids the problem of sending a shared secret key first. Let's finish with the summary. Encryption protects data by making it unreadable to unauthorized people. Plain text is readable data and ciphertext is scrambled data. Symmetric encryption uses one shared key. Asymmetric encryption uses a public key and a private key. The public key encrypts, the private key decrypts, and asymmetric encryption avoids the key distribution problem. Thank you for watching. Like and subscribe for more IGCSE Computer Science revision. Visit www.tuitionharbour.com or email hello@tuitionharbour.co.uk.